Your AI pipeline broke at 2 a.m. Nobody was awake. But by morning, it had already fixed itself. That's not science fiction. That's what MetaAgent does. It watches your agents fail in production in real time, reads the error traces, and rewrites the harness code automatically. No human intervention. No ticket filed. No pager alert. Let's talk about what that actually means in practice. Most AI pipelines today are brittle. You build an agent, it works in testing, you ship it, and then 3 weeks later the upstream API changes its response format, or the model starts returning malformed JSON, or a timeout cascades into a silent failure. You find out because a user complains. That's the status quo. MetaAgent sits above your existing agents, it's the meta layer. It consumes live execution traces, the inputs, the outputs, the errors, the latency spikes. It parses what went wrong, identifies the failure pattern, and generates a new version of the agent harness, the scaffolding code that wraps your LLM calls, handles retries, parses outputs, and routes results. The harness gets rewritten. The agent keeps running. You get a diff in your repo and a summary of what changed. Here's a concrete example. Say your agent is supposed to extract structured data from unstructured text and return a JSON object. The model starts hallucinating an extra field, a field your downstream system doesn't expect. The pipeline breaks. MetaAgent sees the error trace, identifies that the output schema is diverging from the expected contract, rewrites the output parser in the harness to add a validation and stripping step, and redeploys. The agent is now self-consistent again. The system uses what the project calls live traces, not synthetic test cases, not staged failures. Real production errors. That distinction matters because synthetic tests miss the long tail of weird inputs that only show up in production after thousands of real requests. But here's the thing, and this is where honesty matters, MetaAgent is not magic. It rewrites harnesses, not the agent logic itself. If your core prompt is wrong, if your model is fundamentally confused about the task, MetaAgent won't fix that. It's patching the scaffolding around the engine, not rebuilding the engine. It also can't resolve failures that require domain knowledge to fix. If your medical data extraction agent starts failing because the hospital changed their coding system from ICD-10 to ICD-11, the error trace alone doesn't carry enough semantic context for the MetaAgent to understand why the new codes are valid. It might generate a patch that silences the error without actually solving the underlying problem. That's a real risk. And right now, the system requires reasonably structured error traces to work well. If your agent is swallowing exceptions silently, which, let's be honest, a lot of production code does, MetaAgent has nothing to work with. Garbage in, garbage out, even for self-healing systems. What surprised me was how close this is to being genuinely useful in a narrow but important niche, infrastructure-level agents. Think orchestration agents, data pipeline agents, API integration agents, places where the failure modes are predictable and the fixes are structural, not semantic. That's the sweet spot. Realistically, in the next year or two, this kind of meta-layer tooling could become standard in agent frameworks. Imagine LangChain or Crew AI shipping with a MetaAgent sidecar that monitors your deploy flows, flags degradation patterns, and proposes harness patches as pull requests to your repo. That's not far-fetched. The infrastructure is basically already here. The more interesting future is when MetaAgent starts building a library of failure patterns, a kind of immune system memory for AI pipelines. Your agent fails, gets patched, and that patch becomes a template that protects every other agent with a similar structure across your entire organization. Self-improving infrastructure that gets smarter every time something breaks. If you're running this on cloud infrastructure, something like DigitalOcean's app platform actually pairs well here. You get straightforward deployment with the kind of logging and trace access that MetaAgent needs to do its job. Worth keeping in mind if you're setting this up. So why does this exist? Because the people building production AI systems are running out of bandwidth. Deploying an agent is the easy part. Keeping it working silently, reliably, at scale, is where the real work is. And that work right now falls entirely on human engineers who are already stretched thin. MetaAgent is an attempt to push some of that maintenance burden back onto the system itself. It's not trying to replace the engineer. It's trying to stop waking them up at 2 a.m. for a problem the system could have handled on its own. Is it production ready today? Not broadly, no. Is it pointing at a real problem with a credible approach? Absolutely. The GitHub link is in the description. Go read the trace parsing logic, that's where the real interesting engineering is hiding. Next episode, we're looking at a tool that does something similar but for model evaluation, automatically detecting when your model has silently gotten worse without any redeployment. If that sounds familiar, it's because it's the same underlying crisis. Subscribe so you don't miss it.